So the directions say that we're going to put our answers, our thetas, are going to be between 0 and 2 pi. What does that mean about my degree, or my angle that I find? In radians, it's not degrees. We can think about it in degrees, but our final answer has to be in radians. So I'm going to look at this and I'm going to say, all right, I need to get cosecant theta by itself. So what should I do first? Okay. So subtract the 2. Then we're going to divide by radical 3. And I have theta by itself. What did you say? Do I have to rationalize? If my final answer was -2 over radical 3, I would rationalize it. But what am I trying to find for my final answer here? Well, it won't be degrees, but the angle measurement, the theta. That's what I'm trying to find. So that's not my final answer. I'm not going to bother to do that if it's not my final answer. Okay? So what I need to know, though, is I need to know where cosecant theta equals this, but I don't have the cosecant memorized. But I have sine memorized. So what do I know about sine and cosecant? They're not opposites. They are reciprocals. Opposite means plus minus. Reciprocal means split. So I know the reciprocals, so I can think to myself, sine theta should be negative radical 3 over 2 at the same place that cosecant theta is negative 2 over radical 3. These are the exact same location. So when it's like that and I don't have it memorized, I just flip it and change it into the one I do have memorized. Okay, so my next step is I'm going to draw a picture because I need to make sure that there's all of the answers and I'm not making any silly mistake. So I'm thinking to myself, where is sine negative? The bottom 2, because sine is y, and the top 2 is where y is positive. Bottom 2 is where y is negative. Or you think all students take calculus, it's going to be the bottom 2. So we're going to have an angle here. Ooh, that's not what I want to do. I have an angle here, and we'll have an angle, I'll do 2 different colors, here. Okay, we're going to have bottom 2. Because sine is negative. And what's positive in the fourth quadrant? So is sine positive? Almost all of these are going to have 2 answers. The ones that wouldn't have 2 answers would be like when they're on the axis. There's only one place where sine is negative 1. That's on 270 degrees. So most of them are going to have 2 answers. Okay, so now what we have to do is we have to figure out what the reference angle is. And some of you are yelling 60 degrees, which is correct, except we are going to do in radians. So 60 degrees is the reference angle. That's like here to the x-axis. Here to the x-axis is 60 degrees. But when I find my final answer, I need from 0 all the way around to that purple line. And I need it in radian form. What is 60 degrees as a radian? Pi over 3. Because 60 goes into 183 times. So if I go with that light purple line, if I go from 0 to here, how many pi over 3 is that? 4. Oh, I'm sorry, I'm only going to that's 3 pi over 3. I'm just like, going through the process. 1 more pi over 3 makes 4 pi over 3. If you could look at it and know that without thinking 3 pi over 3 for a second. So I know that my first answer is going to be 4 pi over 3. So my second one starts at 0, goes all the way around to here, and there's 1 more pi over 3 left. So you could go this way and say, well, that 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. You could think like all the way around that way. Or you could think this one is 6 pi over 3 and go backwards 1 pi over 3. It would be 5 pi over 3. So I'm going to have two answers for most of these. Okay? Does that help with the cosecant? So I just think about sine because these are the same.
Part of that's confusing is where you place the thing with that.
Mm-hmm.
I mean, I know which parts are positive.
Okay, so what if I ask you, same directions, we'll put our answers from 0 to 2 pi, because I feel like that's when we need more practice with anyway. What if I want to know where Nope, I don't want to do that. Nope, don't want to do that one. Sorry. I want to do this one. I feel like we already did this. Doesn't matter. We'll do it again. So the first thing I'm going to do is this is already solved. So I'm going to draw. And I'm going to think about where cosine could possibly be named. It's positive. Where it could possibly be positive. It's going to be like over here somewhere. That's where cosine's positive. But this one's special. Because the only time cosine or sine could be 1 on the line. At the ordered pair, 1, 0. So what radian is that? Okay, so I'm hearing, is it 0? Is it 2 pi? Is it both? Let's look at our directions. What does this mean? Greater than or equal to 0. What's this mean? Only less than 2 pi. So that means if it's the same, 0, 2 pi, you only use 0. So this answer, theta, would be 0. And there, we only have one answer for that one. So that's the only place. Oh, we don't only have one answer. Yeah, we only have one answer. Because what is it over here? What's it over here? I know, what's the order pair over here? Negative 1, 0. So cosine would be negative 1 there. Here it's positive 1. So there's only one place where it's positive 1. Okay. Yes, Marsh?
How do you say 0 is
0. You just don't put degrees. If you need, like, you're like, that's super easy, you want to write the word RAD, that's not 2 degrees. But if I put 0 degrees, then it means degrees. And 0 degrees and 0 radians are the same number, so it's okay. Okay, now we're going to add on. So the last 3 questions, right? There's only 3 left? Yeah. Last 3 questions. These are the same thing. These just have some more tricks to them that make them more rigorous. So those of you that are like on the track to go to Trig class next year, this is the more rigorous one. If you're on track to go to Trig next year, this might be a little hard, but you actually will do this next year too, so we're all doing it. Okay, I need to solve for sine theta. What should I do first? Add the 2. Oh, there's a little trick here we haven't even talked about. I'm going to go up to the side and talk about it just real fast. If I multiply sine theta times sine theta, this is the sine at an angle multiplied by the sine at the same angle. Give me an example of an angle that we know the sine of. Okay, so this would be the same like sine of 30 degrees multiplied by sine of 30 degrees. So you would find the sine of 30 degrees first, which is 1/2. And then you would multiply that by 1/2. So what is really happening is we are squaring the sine of the same angles. We are not squaring the angle. We are squaring the sine at that angle. So when I see sine squared theta, that means we've got sine of the same theta multiplied twice. But it's weird where we put the squared sign. We're not putting it on the angle because I'm not multiplying 30 times 30. Not 900 degrees. Okay? So that's why it's written that way. Because this is what's happening. Just see. So now let's get down to sine theta. What do I do next? Divide by 4. Okay? Now we have to get rid of the square. How do you get rid of square? Square root. But it doesn't affect theta. It just affects the sign. When I square root, what else do I do? Plus minus. Good job. The square root of 1 is 1. Remember, this is the same thing as plus minus square root of 1 over square root of 2. You can separate the square root. Square root of 1 is 1. Square root of 2, I don't know. If that does not look familiar to me, maybe if we rationalize it, it will look familiar. I don't have to rationalize it because that's not going to be my final answer. But if it doesn't look familiar and you rationalize it, maybe then it looks familiar. So we are trying to find where, at what theta, sine is equal to positive or negative radical 2 over 2. We know that's the reference angle. But remember, we've got positive or negative, so I'm going to draw a picture. Where is sine positive? Top half. So here's 1. Here's 1. And those are 45-degree reference angles. Where else? I'm sorry. And then you have to find where sine is negative also. So the bottom two. Here's my theta. That's a 45-degree reference angle. Or over here, theta, 45-degree reference angle. So how many angles am I going to have in my answer? 4. Now, do the directions say degrees or radius? Degrees? Okay. So we're going to find 4 different degrees. Let's start with the blue one. What's the answer for the blue one? Okay, now the green one starts at 0, rotates around, has 45 degrees more to get to 180. So 135. The purple one starts at 0, rotates around, is 45 degrees past 180. 225. And the red one starts at 0, rotates around, has 45 degrees left to get to back to 2 pi. How much is that? All the way around 360. It's going to be 45 less than 360. 315. I couldn't understand what you were saying. So we have our 4 answers. It's not bad. You just have to remember to do plus or minus, because if you forget plus or minus, you only got half your answers. Okay? Next. Now you're really going to like me.
Oh.
If it's positive and negative, then you'll have the 2 on top and the 2 on bottom. Square. Yeah. That's the only way you can get one. Okay. Kind of. Okay, guys, I'm going to give you an example of things that you've done in here that I would say are similar to what we're about to do. Okay. We have to solve for theta. I'm going to write this without the word sine and cosine, or I write them in a little different. It's things we've done in here. Let's say, example, how would I solve something that's like If I'm ignoring the sines and the cosine, I'm just looking at something like this, okay? How do you solve something that has a squared in it? Factoring or, well, that's factoring. Factoring or complete the square or quadratic formula. GCF, is this factorable? What's the GCF? Okay, so I would do x multiplied by 2x take away 1 equals 0. Remember when you do the GCF, I probably should have written this, you divide each of them by the GCF, and then that GCF goes in front of the parentheses. You don't get rid of it. Then what do we do once we've factored it? Set each factor equal to 0. So we say x equals 0, then we say 2x minus 1 equals 0. Then what do you do? Solve each factor. That one's solved. This one would be half. Okay? So we have done this before. We just haven't done it with sines and cosines. So let's look. Is there a greatest common factor? What is it? Not just sine. It's always sine of an angle, so you are going to factor out sine of theta. That's going to leave me with 2, what left over? 2 cosine theta subtract 1 equals 0. Now what do we do once we've factored out that greatest common factor? What did we do over there? Set each factor equal to 0. So I'm going to say sine theta equals 0. And then I'm going to say 2 cosine theta minus 1 equals 0. So I set each factor equal to 0. And we're going to have to solve each factor. So I like pictures to help. I have to think about where sine could possibly be 0. Remember, sine is y. Where on this unit circle is y 0? On the x-axis. In 2 places, too. At 1, 0 and at negative 1, 0. So what degrees is the first one? 0 degrees. What degrees is this one? So we answered that one. 0 and 180 are the answers for this part. We'll go to the black one, and we'll have 2 cosine theta equals 1 divided by 2. Cosine theta equals a half. So now I have to think, where is cosine theta equal to a half? So I'm going to draw my picture. Where is cosine positive?
Right.
First quadrant and fourth quadrant. What is the reference angle? Where is cosine half? 60 degrees? Those are the reference angles. How we find the real angles. The first one would be 60 degrees. What's the second one? 300. Now we put all of our answers together in order. 0 degrees, 60 degrees, 180 degrees, and 300 degrees. So we're going to solve 2 different parts, and then we put the parts all back together. Yeah. You could get 2 of the same answers from the different parts. If you get 2 of the same answers, you only write that answer once. Thank you. Good question. Okay, so the last example, 2 cosine squared theta minus 3 cosine theta plus 1 equals 0. I'm going to give you an example of something we've done that's similar to that. I'm just saying ignore the cosines and I'm going to pretend like they're x's or something.
You good?
We have solved equations that are quadratic trinomials like that. What are our methods of solving when we have a square? Factoring, quadratic formula, complete the square. Well, GCF would be factoring, yeah. Okay. So let's see if it factors. Because that's my favorite. Remember, if the last sign is positive, they're going to be the same sign, which will be both negative. The last number is 1. There's only one way that I could get 1, and that's 1 times 1. So now I just have to place 2x and x in the correct spot. But that should be pretty easy, huh? Does that work? This would be minus 2x. This would be minus 1x. Does that equal negative 3x? Okay. Then we factored it correctly. Then what do we do once we factored it? We set each factor equal to 0. And then we solve each factor. So we'd have x equals a half. We'd have x equals 1. That is what we learned to do. Now we're applying it to trigonometry. So my first step is I notice this is a lot like a trinomial. I'm going to see if I can factor it. So when I go and I guess and check factoring, my signs are both going to be the same. They're both going to be minus. How do I get this 1 in the last spot? 1 times 1, that has to be. How do I get 2 cosine squared theta in the first spot? No. Oh yeah, one of them's going to be 2 cosine theta. The other one will be cosine theta. And then I multiply them together and I get 2 cosine squared theta. And I FOIL it back together. Outside I'd have, and this is exactly like this, outside I'd have minus 2 cosine theta, and the inside minus 1 cosine theta. So I get minus 1 cosine theta. I factored it correctly. What's my next step? Set each factor equal to 0. So I have 2, I'll do these in 2 different colors too. 2 cosine theta minus 1 equals 0. And cosine theta minus 1 equals 0. So we're going to solve each of these separately. So I have 2 cosine theta equals 1, so cosine theta equals a half. Solve the green one. Cosine theta equals 1. Now we have to go to our picture. And I'm going to concentrate on the purple one. That is positive for cosine. Where's cosine positive? First and fourth on the right side. So we'll have a theta here, and we'll have another theta here. They're both going to have the same reference angle. So now I need to know where is theta, where is cosine a half, what reference to? 60 degrees. That's reference angle. Now, if it's in the first quadrant, then that really is a 60-degree angle. So one of my answers is 60 degrees. If it's in the last quadrant, I just start at 0, go all the way around. I have 60 left. That's going to be 300. So those are the purple answers. Now I'm going to do the green ones. The green ones are where is cosine equal to 1? At that ordered pair, which is 1, 0. So 0 degrees. Is there another location that cosine is 1? There's just one answer for that one. So our final full answer is going to have 3 total answers in it, smallest to biggest, 0, 0 degrees, 60 degrees, and 300 degrees. So it's putting together factoring by solving by factoring, or like all the other solving we've done before, now with trigonometric stuff. So putting together things we've learned before with new stuff. This is how math works from now on until you're done, pretty much. Okay? All right, so you have the rest of class to finish that worksheet, to check answers with me, to ask questions. And if you get done with that, study for the time we take another quiz, just like the one we took before. I don't know, maybe it'll be Friday. What did you say? I told you guys last time too. Oh, just make sure. Bye. Sure. What do you want? Okay, let me.